Hi, welcome back to Elementary Algebra. I'm your instructor, Amy Fuchsteiner. Seems I'm always doing that glasses thing, first time out. We are here today to talk about section 8.5, which is where we're going to multiply and divide some radical expressions. These are expressions with roots. We've talked about the different radical and radicand, etc. And we're going to do a little bit of operations with them. So we're going to start with the product rule for square roots. And the product rule for square roots simply says, if you have the square root of some number m, and you multiply that by the square root of some number n, so these are two numbers, this is the same as the square root of m times n. Right? Now, it is worth noting that m and n should both be positive numbers. So m and n are both positive. Because we can't take the square root of a negative number. We are not allowing for that possibility right now. So some examples. Just to work through some, we've got the square root of 7 times the square root of 5. This would be equal to the square root of 7 times 5, which is the square root of 35. Right? The square root of 35 does not simplify, as there are no numbers that go into 35 other than 7 and 5, and neither of those can be simplified. So that's all we're doing on that one. Problem number 2 is the square root of 15 times the square root of 10. That would be the square root of 15 times 10, which is going to be the square root of 150. We can simplify the square root of 150 either by using the prime factor method or by using the largest perfect square. I'm going to go ahead and do the largest perfect square. This is the square root of 25 times 6, which is the square root of 25 times the square root of 6, or 5 square roots of 6. And then we'll just leave it at that. For number 3, we have 2 times the square root of 5 times a negative 5 times the square root of 15. To simplify this, we multiply the 2 times the negative 5. Both of them are outside of the square root. This would be times the square root of 5 times 15. Now, negative 2, or 2 times a negative 5 is a negative 10. I can do that multiplication. I can break down the 15, so I have 5 times 3. This is using a prime factor method in order to simplify the square root. Since I have 2 5s there, I can bring 1 out front. This would be a negative 10 times 5 square roots of 3, which is a negative 50 square root of 3. And I'm going to leave it at that. Okay. Adding variables into the mix. First of all, we're going to assume that all variables here are also positive numbers already. That saves us a little bit of stress in worrying about what happens when they're negative. So we're going to assume that all variables are positive. Again, we have a 3 and a 2 both outside the square root. So we're going to multiply those as 3 times 2. Then we will have the square root of x times the square root of x to the third. This will give us 6, 3 times 2, the square root of x to the fourth. The square root of x to the fourth is x squared, so this will just be 6x squared. Blocking that one off. All right. 5 square root of 3a minus 11, or minus the square root of 11a, or times a negative. That's not actually subtraction. That's times a negative 1 square root of 11a. So this would be 5 times a negative 1 times the square root of 3a times 11a. That's going to give us a negative 5 square root of 33a squared. I cannot take the square root of 33. That's just a 3 times 11. So the square root of 33 cannot be simplified. The a squared Square root of that is indeed an a. So this will be a negative 5a square root of 33. And we're good at that one. What happened with number 6 there? Number 6 there is working backwards a little bit. But hey, that's okay. No variables is still the same idea. We want to do 6 times 5. And then we're going to multiply that by the square root of 8 times 12. Now, since I already have the factors here, this is going to give me 30. 8 is 2 times 2 times 2. 12 is 2 times 2 times 3. Using my prime factorization method, I have 1 pair of 2's, 2 pair of 2's, and the 2 times 3 does not have a pair. So this will be 30 times 2 for the first pair, times 2 for the second pair, times the square root of 6, or 120 square roots of 6. Oh, we're blocked there. We got 120 square roots of 6. All right. How are we doing so far? Feeling all right with those? Okay. So the second goal in this section is to find the powers of the square roots. In order to do that, we simply ask you to recognize that the square root of x, any number, when squared, is going to give you what is underneath the square root. So squaring a square root will get you the radicand. Simple as that. All right. So when we multiply 2 times the square root of 5 and square that, if we write it out, this is going to be 2 times the square root of 5 times another 2 times the square root of 5. Seeing it written out like this, we hope that you recognize that this is just going to be 2 times 2, which is 4. And the square root of 5 times the square root of 5 is the square root of 25, which is just 4 times 5, or 20. There we go. I can use this, and I can do this slightly differently by seeing it as a negative 3 squared and a square root of 2x squared, right? Product rule, way back from earlier, I can use the product rule, and I can put that 2 on the negative 3, and I can put that 2 on the root 2x. So this will get me 9 times the square root squared is going to just get me 2x. So this is going to be 18x. All right. Why did I show you that? Well, because we're going to kick it up a little bit further, and we're going to multiply some binomials, some radical expressions that are actually binomials. So here we have the square root of 3 times the binomial, 2 square roots of 12 minus 3 square roots of 2. So that means I'm going to distribute that root 3 just as we normally would, there and there, right? Giving me 2 times the square root of 3 times 12 minus 3 times the square root of 3 times 2. This is 2 times the square root of 36 minus 3 times the square root of 6. The square root of 36 is 6, so 2 times 6 minus 3 square roots of 6, or 12 minus 3 square roots of 6. I cannot combine the like terms. I cannot combine because I do not have like terms. So this is going to just be 12 minus 3 square roots of 6. I want the yellow one for the box. There we go. Boxing it in. And we're good. What do I do if I have a binomial times a binomial? Same as if we had regular ones. We're going to do the first, which is going to be the square root of x times the square root of 5x. That's going to be the first. Now we're going to do the outside. So minus the square root of x times 3 square root of 3. Then we'll do the inside, plus 2 square root of 3 times square root of 5x. And then we've got the last, that's going to be plus 2 square roots of 3 times, minus 3 square roots of 3. I hate when I run out of room. Okay, so this will be the square root of 5x squared minus 3 square roots of 3x plus 2 square root 15x plus 2 minus 3. So that's going to be a minus 6 square roots of 9. So the x squared, I can bring an x out. So this will be x square root of 5 minus 3 square roots of 3x. Can't do anything there. That's the same. 3 square roots of 3x, going to stay the same. Plus 15x, I can't do anything there. That's not going to be simplified. Plus 15 is just 5 times 3. That no perfect squares there. It's not going to break down. Minus 6 times 3. So I've got x square root of 5 minus 3 square roots of 3x plus 2 square roots of 15x minus 18. And that's it. That's as much as I can do there. I'm going to move this over. There we go. That's as much as I can do. Sometimes, without like terms, that's as good as we can get it. All right. Let's see. We're going to kick it up a little bit more. Here I have the square root of 23 minus r, that quantity squared. Now, the temptation here is to just square the first and the last. That's not going to work because this is going to be the square root of 23 minus the square root of r times the square root of 23 minus the square root of r. Right? This is our typical square, multiply, double, square. So if you're using that pattern, it's going to be the square root of 23 squared. Then we're going to have a minus square root of 23r. The inside would be a minus the square root of 23r. Minus a minus is plus the square root of r squared, or 23 minus 2 square roots of 23r plus r. Yeah, that works. Now, some people will rearrange this slightly. So we have an r minus 2 square roots of 23r plus 23, because they like having the letter first and the constant last. But there's really not a big difference there. Right? And that is simplified. Problem number 12 is the difference of two squares. You see that minus and that's a plus, and they're the same. So this is going to fit our other pattern. All right, if I do the first, that's going to be the square root of y times the square root of y. So that's going to be the square root of y squared. Plus, that's going to be a minus. So outside would be square root of y times the square root of 7. So that'll be minus the square root of 7y. The inside would be the square root of 7 times the square root of y, or plus the square root of 7y. And then the last would be minus the square root of 7 squared. So this is going to be y minus 7 root 7y plus root 7y. Those are going to cancel. And I'm going to have minus the square root of 7 squared is just going to be a 7. This is the difference of two squares. We did this a couple of chapters ago. Chapter 6, I think this was. Yeah, chapter 6. One of the factoring patterns. Difference of two squares. Square the first minus the square of the second. Right? Great. We're working those patterns in. All right. Goal number 4. We want to divide our radical expressions. So, yeah. Square root of 30y to the 9th over the square root of 160y to the 5th. So how am I going to simplify this? All right. I can use, do you remember that the square root of a over b is equal to the square root of a over the square root of b, right? Is it also true that the square root of a over, does it have to go both ways? It does. So for this guy, I might actually do this as 39 to y over 160y fifth. And then I'm going to cancel. Bam, bam. You divide both of those by 10 to get 3 over 16. And then I have y to the ninth over y to the fifth. That's going to be y to the fourth. And it'll be up top. And I need the square root of all of that. So this will be the square root of 3y to the fourth over the square root of 16. Well, the square root of 3 I cannot do. So that's just going to be the square root of 3. Y to the fourth, the square root is y squared, or 4 divided by 2. The square root of 16 is 4. So I have y squared, square root of 3 over 4. Beautiful. Okay, I don't have to do it that way. I can simply factor this as the square root of 3 times 5 times x to the 11th. Since I need an x to the 5th, I'm just going to write it as x to the 11th. All right, 125. So we're going to have the square root of 3 times 3 times 5 times 5, x to the 5th. I could cancel, but I don't want to. I like this method better here. I'm going to backtrack this guy. I'm going to rewrite this as the square root of 15x to the 11th over 125x to the 5th. I'm going to cancel these guys and get x to the 6th. And I'm not going to cancel the 15 because 125 I know is 15 squared. So I'm going to have the square root of 15x to the 6th over the square root of 125. X to the 6th, I can take the square root of, that's going to be x to the 3rd. The square root of 15, I cannot. The square root of 125 is 15. So I'm going to have x to the 3rd square root 15 over 15. I'm choosing this method because in simplest form, if you recall, we cannot have square roots in the denominator. So while I could have canceled the 15 and the 125, that would have left me with a square root in the denominator, which technically I can't have. How do I deal with it when it occurs? That's what we're going to talk about in this last piece. This last piece is what you need to do to rationalize a denominator. So when you get a square root or root of any kind in the denominator, we need to raise that denominator to a perfect square. That's why I didn't touch the 125 last time. I know I need a perfect square in the denominator to rationalize it. So whatever's missing to make it a perfect square, we're going to multiply both the numerator and the denominator by that root to raise it. We're going to simplify the numerator. It may or may not remain a square root or a radical expression in that numerator. And we're going to rationalize the denominator. Now, we should eliminate all radicals from the denominator. The radical expression should be eliminated. Here's how it works. All right, so I have the square root of 5/3. This would be the square root of 5 over the square root of 3. I have a square root in the denominator. That cannot stand. If you want to know why, ask, but we cannot have a square root in the denominator. In order to eliminate that square root in the denominator, I need to raise this to the square root of a perfect square. We know we can multiply this by another square root, and that would make it the square root of 9, which is a perfect square. So I'm going to multiply the bottom by the square root of 3. Because it is a fraction, what I do to the numerator, I must also do to the denominator. So I'm going to multiply the numerator by the square root of 3. This is the same as multiplying by 1, right? Because 3 over 3, square root of 3 over square root of 3 is still a 1. So I am technically multiplying by 1. I'm changing the look of this particular fraction, but I am not changing its value. This will give us square root of 5 times the square root of 3 is the square root of 15. The square root of 3 times the square root of 3, square root times itself is the radicand. So this is a square root of 15 over 3. I cannot simplify anymore. This is it. And the square root of 15 over 3 is my final answer. I still have a radical expression in the numerator, but I have eliminated it in the denominator. Let's look at problem number 16. Problem number 16 is the square root of 100a over 18b. This is going to be the square root of 100a over the square root of 18b. Okay, I can simplify the numerator. You feel free to do that. That's going to be the square root of 100. That's 10 times the square root of a. Can't find the square root of a. Then in the denominator, I have 18b. That's not a perfect square. So I'm just going to leave it square root of 18b for now. If I want this to be a perfect square, I'm going to need to multiply by another b to get a b squared. So I'm going to need a b. Now, what can I multiply 18 by to get a perfect square? I happen to know that 18 times 2 is 36. So 36 is a perfect square. So I'm going to multiply both the denominator and the numerator by 2b. It's the same as multiplying by 1, so I'm not changing the value. But what does happen is I will get 10 square roots of 2ab. And then in the denominator, I will have the square root. 2 times 18 is 36. B times b is b squared. I can simplify the square root of 36. That's 6. And I can simplify the square root of b squared. That's b. The only thing we may want to reduce here is the 10 over 6 to a 5 and a 3. So that's going to give me 5 square roots of 2ab over 3b. I no longer have any radical expressions in the denominator. They do still exist in the numerator, but the numerator is fine. I just cannot have them in the denominator. Let's try number 17. Now, number 17 is the square root of 5 over the square root of x minus 3. I need to eliminate the square root of x because I cannot have a square root in the denominator. This one is a rough one. The trick here is to think of this as a binomial and to remember our factors from before. I'm going to multiply this using the difference of squares. We did this problem 14, I think it was, on the last page. So if I multiply by the square root of x, this is minus plus 3. Not only in, I should have done that in blue. so that you could tell it was a move. Square root of x plus 3 in the numerator, or in the denominator and in the numerator. What's going to happen here is I'm going to have the square root of 5 times the square root of x plus an entire 3 over the square root of x minus 3 times the square root of x plus 3. In the numerator, I can just distribute. That was a face. I just pulled a great face there. But in the numerator, I can just distribute. That's going to be the square root of 5x plus 3 times the square root of 5. And that's fine. In the numerator, I just just distributed as I normally would. Now in the denominator, here's where we get a beauty. We're going to have the square root of x times the square root of x. That's going to be an x. We're going to have the square root of x plus, or we're going to have square root of x times 3. So that's going to be plus 3 square root of x. We're going to have 3 times the square root of x minus, so we're going to have minus 3 square roots of x. And then we're going to have a negative 3 times a positive 3, which is 9. Do you see how I manipulated what I'm multiplying by so that my middle terms, my outside and my inside from FOIL, will cancel out? That's why I just did the opposite sign of whatever was there. So this is going to give me the square root of 5x plus 3 square roots of 5 over x plus 9. And now I do not have any radical expressions in the denominator. And I cannot simplify any radical expressions in the numerator. So this is as far as I can go. All right? There is some tough stuff in this section. If you have any questions, please don't hesitate to reach out. You can contact me or you can reach out to the Math Center. We are all here to assist you. We want to see you succeed. All right? Thank you, and we'll see you next time.